Hello everyone. Today again I am here to discuss you the type of constrained motion in the subject theory of machine. Myself, the Dr. Ishad Ahmed Khan, working as Associate Professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal, under SAES Group. So let's discuss about today's subject, constrained motion. So we have the three type of constrained motion between the elements of pair: completely constrained motion, uncompletely constrained motion, successfully constrained motion. Let's discuss one by one with the help of diagram. So first one is the completely constrained motion. When the motion between the element of the pair is indefinite direction, irrespective to apply the force. We have two diagrams here to understand this motion. Let's discuss with first one. This first diagram is the typical example of prismatic pair. So we can see. So as I explained you, the only one direction motion is possible irrespective to the applied force. In this pair, you can see if we applied force in this direction, no motion is possible because this is only make motion along the x-axis. So when you apply the load or force in this direction, then the motion is possible. So in its possess only one kind of motion when you apply the load along this x-axis, you can say, in this element 2. So it having a definite motion. So that's why this is come under the completely constrained motion category. Let's see next one. You can see in the next example here. In the next example, here collar is provided at the end of here, at the end of this point or element 1, and here also. As collar is provided here, so it restricts the motion, this translation motion of shaft along the axis, and only the rotation is possible along the axis of the shaft. This way, this one, this one, this one. Okay, so we can say this pair having one definite motion irrespective to the apply load. So this can rotate only, and this can translate only. So this is called the completely constrained motion category. Next one is the unconstrained motion. When the motion between two elements of pair have more than one direction respective to the applied load. So here we can see this is the example element 1 and this is element 2. This shaft can rotate as well as translate on this hole, depend on the applied load. If we apply the load in axial direction, either push or pull, so this translation is possible. If you apply the torque here or apply twist it, so it can rotate around here about the axis. So two motion is possible here in constrained motion respective to the applied load, depend on the direction of the load. If you be applying this load along the axis, so we can get translation applied this twisting moment, so we will get the motion, angular motion or rotation, we can say, along the axis of the shaft. Last one is that here successfully constrained motion. In successfully constrained motion, this is a typical diagram footstep bearing. This is the footstep bearing. This one said that this hatching part, yeah, hatched part is the footstep bearing, and here the shaft of the shaft is attached here. It may be shaft of the Kaplan turbine. It may. So we can see here, when understand was successfully constrained motion, when the motion between the two element of pair possible in more than one direction, but it's a make motion is only one direction due to some mechanical constraint. So it can motion in two direction. It can rotate or it can be translate about this y-axis, but due to the sub-design constraint or mechanical constraint, it's make only one direction rotation only. So this is called the successfully constrained motion. Here you can say the heavy a load is provided here. So due to this load, it not translate about this axis about y-axis. So this is possessing only rotation, but there is no any collar and all here. So technically it can two direction method, but due to the load in from upward direction, so it's can't translate about y-axis, only showing one possessing one kind of motion. So this is called the successfully constrained motion. So I hope you understand this this concept. This is important part, type of under the type of constrained motion. Thank you so much for listening.